So happy Monday. Yes, I'm not here today. Unfortunately, I am in meetings, so I'm not skipping school. I'm not just at home chilling on my couch. I would rather be in school than at these meetings all day. But all right. So today we are starting chapter 6, and it's the first day of chapter 6. And chapter 6 is called Piecewise Functions. All that we're really doing is graphing multiple different equations on the same graph. So instead of just graphing like 3x plus 2, we're going to graph that, and we're going to graph a quadratic, and we're going to graph an exponential. We're going to put a bunch of different graphs on the same graph, a bunch of different equations on the same graph. So, all right, before we do that, let's go over the warm-up. So reviewing, if we have f of x is just a fancy way of writing y equals. So if we have f of x, that's just a fancy way of saying y equals x minus 1 squared over 3. And then it says find f of negative 4, f of 1 half, and f of 5. All this means to do is plug these numbers in to the equation for x. All right, so let's do that. What does that mean? So we have f of x, and then it says find f of negative 4. So that means find the value of this function if we plug in negative 4. So plug in negative 4 for x. So we have, my board is not working. Perfect. Hold on, bear with me. See if we can get the board to work. There we go. All right. So f of negative 4, plug in negative 4 for x. So f of negative 4 equals negative 4 minus 1 squared over 3. So plugging in negative 4 for x. All right, negative 4 minus 1 is negative 5. So we have negative 5 squared over 3. When you do this on the calculator, make sure that you keep negative 5 in parentheses. So negative 5 squared is negative 5 times negative 5, which is a positive 25, divided by 3. So this gives us 25 over 3. And that's some sort of decimal, but I'm just going to leave it like that. All right, plugging in 1 half. So f of 1 half means 1 half minus 1 squared all over 3. So it's negative 0.5. So 1 half minus 1 is negative 0.5 squared over 3, which becomes 0.25 over 3. And if you plug 0.25 divided by 3 into your calculator, do it now. Do 0.25 divided by 3, hit enter, and then do math, enter, enter. It will give you 1/12. So this whole thing equals 1 over 12. All right, then the last one, plugging in 5. So we have f of 5 means do 5 minus 1 squared over 3. So that's 4 squared over 3, which is 16 over 3. That's some sort of decimal, but we're just going to leave it like that also. Okay, so that's a recap. Plugging in values. Make sure you always keep them in parentheses, the thing that you plug in. All right, so today's target, we're going to evaluate piecewise functions for given x values. That means we're going to do like we just did in the warm-up. We're going to plug in x values to equations and figure out what it equals. And we're going to graph these things. So we're going to put multiple different equations on the same graph. The easiest way to do that is by making a table. Anytime you're confused on how to graph any equation out there in the world, make a table. All right, so a piecewise function is a function which is defined by multiple subfunctions. So basically, this means we're putting multiple equations graphed on one graph. So multiple equations graphed on one graph. Okay, that's what it means. We're putting multiple different equations on the same graph. So here's our first example. We're saying, here's one of the equations to graph, 3x squared minus 5. You only graph that if you are plugging in x values that are greater than or equal to 4. So if you're going to plug in 4, 5, 6, 7, 8, then you are going to use this top equation because it says use this equation if your x value is greater than or equal to 4. If we're going to plug in something less than 3, so if we're plugging in 2, 1, 0, something like that, then we're using this bottom equation. So it says plug it into the top one if the x value is greater than or equal to 4. Plug it into the bottom one if your x value is less than 3. All right, so let's practice a couple of these. It says find h of 0. So, do we plug it into the top or to the bottom? Well, 0 is less than 3, so we are plugging into the bottom one. 0 is not greater than or equal to 4, so we can't use the top. We have to use the bottom. So, to find h of 0, we're plugging into that bottom equation, plugging in 0 for x. So, we have 2 times 0 plus 15, which is 0 plus 15, which is 15. Okay, for the next one, 3.5. Okay, where do we plug that one into? It says, use this top one if your x value is greater than or equal to 4. 3.5 is not greater than or equal to 4. Then it says, use this bottom one if your x value is less than 3. Well, 3.5 is not less than 3. So 3.5 doesn't fit into either of these. So for this one, we actually say no solution. Because 3.5 is not greater than 4, so we can't plug it in up here. And 3.5 is not less than 3, so we can't plug it in down there. So we don't have anywhere to plug it in, so it's a no solution. All right, the last one, h of 4. Here it says plug it in if the value is less than 3. 4 is not less than 3, so not the bottom one. The top one says if it is greater than or equal to 4, use this. So 4 is equal to 4, so we're using the top one. So to find h sub 4, we have to plug it into the top. So it becomes 3 times 4 squared minus 5, which is 3 times. Do order of operations. Please excuse my dear Aunt Sally. Exponents comes before multiply. So you must do 4 squared first. So 3 times 16 minus 5. 3 times 16 is 48. 48 minus 5, so this whole thing equals 43. Okay, so that's step 1. Can you figure out which equation to plug the values into? Step 2 is graph this thing. To graph it, we are going to make a table. We have 2 different equations that we have to graph. We have to graph 3x squared minus 5, and we have to graph 2x plus 15. All right, so first I'm going to make a table for that top equation. So we'll give ourselves some room here. Okay, first we are graphing 3x squared minus 5. Let's make an XY table. However, this equation says only use this if your x values are greater than or equal to 4. So here I have to plug in values 4, 5, 6, things that are greater than or equal to 4. Also, since this is an or equals to, this will be a solid dot when we put it on the graph. Since this is just a less than, not an or equals to, this will be an open dot when we put it on the graph. I'll show you what I mean in a second. But okay, so the x values that we're plugging in up here have to be greater than or equal to 4. So we can plug in things like 4, 5, 6, or 7. Always do at least 3 or 4 points. Okay, so if we plug in 4, that becomes 3 times 4 squared minus 5, which is 43. If we plug in 5, it becomes 3 times 5 squared minus 5, which is 70. If we plug in 6, we get 3 times 6 squared minus 5, which is 103. And if we plug in 7, we get 3 times 7 squared minus 5, which is 142. Okay, that's going to be one of our graphs. We're also graphing the equation 2x plus 15. To graph this, it says that x values must be less than 3. So we have to use things less than 3. I'm going to include 3 on my graph, but when I graph it, I have to use an open circle since it's not or equals to. Okay, so make a table. So x, y, and we have to plug in things that are less than 3. So I'm going to plug in 3, 2, 1. That'll be good. As long as you do 3 or 4 points every time, that's okay. All right, so plugging in 3 becomes 2 times 3 plus 15, which is 6 plus 15, which is 21. 2 times 2 plus 15, which comes out to be 19. And 2 times 1 plus 15, which equals 17. Okay, now we have a bunch of coordinate points that we can plot, like 4, 43, 5, 70, 2, 19. Those are all points that we're going to plot on this graph. So make yourselves a nice coordinate plane here. So we have our y-axis, and we have our x-axis. Okay, and in the x direction, I have to go from 1 to 7. So I can count by ones. 1, 2, 3, 4, 5, 6, 7. Yeah, I can count by ones down here. And I just looked at my x values. I saw the lowest one was a 1, and the largest one was a 7. So I went from 1 to 7. And in the y direction, we have to go from 17 all the way to 142. So I'm going to count by 20s. So 20, 40, 60, 80, 100, 120, 140, 160. Okay, now we just simply plot our coordinate points. So when we plug in 4 up here, this first equation said that it was greater than or equal to 4. So when we plot the point 4, we have to use a closed circle. When we plot the point 3, that was on this second equation, and it says less than. Not less than or equal to, just a less than. So when we plot the point 3, we have to use an open circle on 3. All right, let's plot these. So 4, 43. 4, 43 is somewhere around here. Put a closed circle on 4. And then 5, 70 is somewhere around here. 6, comma 103 is somewhere around here. And 7, comma 142 is all the way up here. All right, so we can go ahead and we can plot those points. And this continues on, so put an arrow going out towards the right. Okay, now let's plot the points for this side. So 3, comma 21. You have to put an open circle there, though. So 3, comma 21 is around here. I made a mistake earlier. 443 is not where that is. So 4, comma 43 is up higher. So 4, comma 43 is about right here. Closed circle, and it swoops up a little bit. Okay, that's better. 3, comma 21. So it's an open circle there. And now 2, comma 19. So we come down below a little bit. And then 1, comma 17. We come down even a little bit further. And this is a line as well. So put an arrow on the end. All right, those are the two things that we're doing today. Can we plug values in, like we did up here? Can we plug them into the correct equation? And then can we graph this making a table? Let's do another one together. So flip the page, on to the next page. This one's a little bit more intense. So this one now has 3 equations. We use the top one if it's an x value less than or equal to 0. The middle one if it's greater than 0 but less than or equal to 3. And the bottom one if it's something greater than 3. Okay, so find g sub 1. So we need to figure out which of these 3 equations should we plug it into. Is 1 less than or equal to 0? The answer is no. So don't plug it in there. Is 1 greater than 0 but less than or equal to 3? So is 1 between 0 and 3? Yes. So we will be plugging it into this second equation. So to find g sub 1, we have to use that second equation because 1 is between 0 and 3. So plug it in. So it's 2 to the power of 1 minus 4, which is 2 minus 4, which is negative 2. All right, g sub 3. So where does this go? Is 3 less than or equal to 0? No. Is 3 greater than 0 but less than or equal to 3? Yes, because 3 is equal to 3. There's a or equals to. So that's how we're plugging in here. This one says the x value has to be greater than 3. 3 is not greater than 3. So we can't plug it into the bottom one. 3 is or equals to 3. So that's why we have to plug it into this middle one. So to find g sub 3, we have to do 2 to the power of 3 minus 4, which is 8 minus 4, which is 4. Okay, g sub 0. So is 0 greater than 0? No. Can't plug it in here. Is 0 less than or equal to 0? Yes, because 0 equals 0. So we're plugging it into this top one. So we have 1/2 times 0 squared means 1/2 times 0 squared means 0 times 0, which is 0. So this whole thing comes out to be 0. Okay, moving on. G sub negative 4. Is negative 4 greater than 3? No. Is negative 4 between 0 and 3? No. Is negative 4 less than or equal to 0? Yes. So here we are plugging negative 4 into the top one. So we have g sub negative 4 equals 1/2 negative 4 squared, which is 1/2 times negative 4 times negative 4 is positive 16. And that comes out to be 8. Notice, multiplying by 1/2 is the same thing as dividing by 2. That was on the quiz that we just done. All right, g sub 11. Is 11 less than or equal to 0? No. Is 11 between 0 and 3? No. Is 11 greater than 3? Yes. So for g sub 11, we're plugging into this third equation. So g sub 11 equals 2 times 11 minus 2, which is 22 minus 2, which is 20. All right, and the last one, g sub 2, is 2 less than or equal to 0? No. Is 2 greater than 0 or less than or equal to 3? Yes, 2 is between 0 and 3. So for 2, we'll be using this middle one. Is 2 greater than 3? No. So we have to plug it into this middle one. So g sub 2 means 2 to the power of 2 minus 4, which is 4 minus 4, which is 0. All right, so that was step 1. Can we decide which equation to plug these numbers into and then solve? All right, step 2 is go ahead and graph these things. So we have 3 different equations that we're going to put on the same graph. To do it, we are going to make a table. Excuse me. All right, so for the first equation, 1/2 x squared. So 1/2 x squared says we're using that only if our x values are less than 0. So use 1/2 x squared only if your x values are less than or equal to 0. So for this equation, since it's an or equals to, we're going to have a solid dot on 0 because it's the or equals to part. Okay, for this equation, we have to plug in values that are less than or equal to 0. So we'll do 0, -1, -2, things like that. So, creating our table, x, y, we can plug in 0, -1, -2, and -3. Don't forget, at 0, we'll have a closed dot because it's or equals to there. All right, plugging in 0, we have 1/2 times 0 squared, which is 0. We have, when we plug in -1, 1/2 times -1 squared. -1 squared is 1 times 1/2 is 0.5. And then so on. When we plug in -2, we get 2. When we plug in -3, we get 4.5. All right, that's our first equation. Next, we are plugging in 2 to the power of x minus 4. So 2 to the power of x minus 4. For this, it says use it if we have x values that are greater than 0 or less than or equal to 3. So at 0, we're going to have an open dot because it's not or equals to, it's just less than. But at 3, we will have a closed dot. All right, so plugging these in, we're using x values that have to be between 0 and 3. So create your table, x, y, and hold on for 1 second. Pause. If I can do that. Can I pause? I don't know. Let's see.